Hi, my original CSWA Practice Exam walkthrough has helped thousands of people, but I've noticed many of you are still getting stuck in the same places. Today, let's fix that. My name's Chris, this is Fully Defined, and in this video, I'm answering your top questions and issues with the CSWA sample exam. Now, if you don't know what I'm talking about, check out this video below where I walk you through the sample exam, mainly the modeling and assembly questions. But for a lot of people just getting into SolidWorks, there are some tricky areas where people can get stuck. I've taken those top comments, both in my Discord and on the YouTube video itself, and answered them in this video. We're going to look at some additional tips for sketching, for viewing sketch relations, for addressing errors with sketches being overdefined or underdefined, and a few little tricks that's just going to smooth the process out for you. Let's jump in. Okay, the first problem we're going to start with is overdefined sketches. Now, I have a great example here from Kenny, who jumped onto my Discord and posted his question in the CSWA sample exams help channel. Use Kenny's image that he's posted along with his question. He's been trying to sketch the shape from question 3. Every time I do so, something is overdefined and I can't end up with the correct geometry. Is there anything I'm doing incorrectly to generate the errors? Any help would be much appreciated. So what you can see here is on this image, a common example of when a sketch is overdefined, where you'll have one or two items, whether it be relations or dimensions, that are red, they're causing errors, they cannot be solved. And then a bunch of other ones which are yellow, which are showing warnings. Typically, if you delete the red relations, the red dimensions, your sketch will go back to underdefined or fully defined in some cases, and then you can continue on. But where I think with ongoing practice, more training, you'll start to understand why the red warnings, the red errors, the yellow warnings are happening, and you'll be able to address it without deleting or changing many things. So I'm going to point out a few things with this sketch before I show you how to deal with it. So first, the red is always worse than the yellow. So deal with the red ones first. Often the yellow will resolve after you've deleted or corrected any red errors. The main thing that we can see in this image is there's no sketch relations being shown. So I can see all the dimensions, but I can't see if there's any errors with any relationships. And what that means is, if we have a look at my file, I edit my sketch, you can see in my sketch all of the green markers for the relations, okay, they're visible. So if they're not visible in your sketch, now, for them to be visible, you need to be editing the sketch. It's not enough just to have a sketch on its own. Even if I can see this sketch here, if I'm not in edit sketch mode, I can't see those relations. So I want to edit sketch. And then if you still can't see them, there's two things you can do, which is either click on this eye icon here. Sometimes users have that on and it's hiding all types. All right, so if I uncheck that and I click the drop down, under the drop down here, there is view sketch relations. Now, if I click that to turn it off, to disable it, all those little green markers went away. Sometimes you want to do this with your sketches, particularly with patterns. Sometimes you might have hundreds or thousands of relations and it really slows down the performance of the software. But generally, you want to keep it on so that you can see and understand. So that's the first thing. If you can't get to it via here, via the hide all types icon, you can also go to the toolbar at the top of the menu, go to view, hide show, and find sketch relations here. It's the same thing. So my suggestion, I'll always work with sketch relations visible so that I can see any errors or I can see any missing relations as I'm working. Now, the answer to Kenny's question was a spot the difference between his file and mine. These differences, they can be very small and deceiving, but that's kind of what we're playing at here. We're playing a bit of a game. The spot the difference. So let me bring it up. All right. So what can you see in the difference between these two sketches? Now the answer is here, that in Kenny's sketch, he had this top line here, coincident or collinear with that construction line and the line across on the right-hand side. Whereas the sketch that we see in the sample exam, there is a distance difference between those 2 points. So the dimension here of 38, that's incorrect. So that's the one that he needs to delete. That's the one which is not on the drawing at all. Needs to delete that dimension. As you can see on the sketch here, that's 38 millimeter dimension that Kenny had in his sketch. That does not exist. On the sample exam drawing, it is a 32. So for Kenny to fix his issue, he needs to delete this dimension. He needs to delete any relationship between this section of the sketch near the chamfer on the left and the one on the right, so that he can drop this line down to the red line that I've sketched, and then he'll be able to put in the correct dimensions. There is another issue in Kenny's sketch that I just want to point out before we move on, and that is the 29 dimension that is up the top here. If we have a look at the drawing, the 29 comes from the outer edge on the right-hand side of the shape. But in Kenny's example, he has the 29 coming from the top point of the angle. So this is another dimension that if he doesn't correct it, he's going to get the wrong answer. It's very important that any dimension you can see here, not just the number being correct, but also where the dimension goes from and to. You want to make sure that you have those selections right as well. If you want real projects to practice with, including Lego models you can download and reference, I've created a free school community. It's the best place to get feedback, ask questions, and practice on real designs. And for anyone who wants structured, deeper preparation for the CSWA, I've built a full course inside school. No pressure, it's there if you need it. The next question or comment I have to respond to is one from Kaya Yende, who's commented on the YouTube video. Hi, I'm struggling to get the masses right from question 2 to question 5. I managed to get the first one right, and I was doing exactly what you were doing. So I don't know why I'm getting incorrect answers. My response was if you get the first one right, then you've done probably the hardest part of the challenge, because you've been able to create the sketch correctly, use all the correct dimensions. In SolidWorks, it should be exact to the 2 decimal points, so you'll know you'll have the right answer. If you don't have the right answer for this first problem, then there's still a bit of work to do to work out, spot the difference and find where you've gone wrong. But if you get the first one right, from there, you have a starting point that you know is correct. You just need to work through the subsequent questions one by one, and if you find you have an answer that is out in those later ones, you need to work back to work out where your problem is. It makes it easier from identifying the issue point of view. So the next questions, you only have to change a couple of dimensions. It should be straightforward, so you want to make sure you follow them correctly. All right, so I'm going to take you through those next steps, just a rehash here, so we can pick up on anything that might have gone wrong in those following 2 questions I think we'll go through. So this is question 3 here in the exam. Now we can see that we've got A being 81, B being 57, and C being 43. C is the extrusion depth. So when I roll down here, I can see extrude, I can see the number 43, right? And the mass of this part, when I check here, we can see the number just here, 939.54 grams, which is answer D. So now there's a reminder here. Save your part in a different file after each question in case it must be reviewed. This helps you trace back your steps, particularly during the real exam. If you get into trouble, you just open up the last question, go from there again and save a new version. So for question 4, the next question, you just have to change those 3 dimensions. You don't have to change anything else. So what I'm going to do here, I'm going to save. I'm going to go File, Save As. I'm going to just change this to question 4. And in this one, I changed 3 dimensions. 3 dimensions. The first one is the number 43. So C becomes 45. So I click on the 43, change that to 45, press enter. That's number 1. Number 2 is A becomes 84. Now, what you'll notice here in my sketch, I have an A and a B underneath those dimensions. So it's very obvious to me what dimensions, where those dimensions are and what needs to change. For you to add that A or B in these dimensions, I'll show you how. You have to be in the edit sketch mode. You have to click on a dimension. You wait for the dimension properties on the left to open up. You see the dimension text box here. Now there is a box above the line and below the line. In below the line is where I've added my text, all right, to signify which letter that dimension relates to. Now I'm just showing you here, this one as an example. You can put any text in that. You can also put brackets around that number or an inspection dimension border. Let's delete that. I'm keeping the dimension, but you can see here for 81, I've got the A, that's in the box below, and I've just put a circle around it so it's really clear. Now, I don't have to edit in the sketch. I can just click, if I've got Instant 3D active, I can just click on the feature here. If I've got Instant 3D active, I can click on the sketch in the feature tree, all right? And then I can see the numbers. And so 81, I can click on here, and that's going to become 84. And 57 is going to become 59. They're the only 3 changes I need to make for this question. So now my answer goes to 1032.32. Now, this is one where you no longer have multiple choice. So you have to write down your answer, and the answers are in the back of the book. If we fly through to the answers, just to check if we've got the right one, we can see question 4, 1032.32. That's the correct answer. All right, so let's do the next question, which would be question 5. And question 5 is slightly more difficult because you're adding some new geometry or taking it away using some cut extrudes. I'm going to save as once again. Question 5. And now for this one, you want to look at the views and you want to work out where you need to add or remove material. We have one from the top view. Let's say top view. Now to rotate my views, I'm holding the shift key on the keyboard and pressing my arrows, and then it's going to rotate 90 degrees at a time. So I can see in the example here, it's asking me to remove 19 millimeters of material there and 24 millimeters in the middle. If I zoom down a little bit, it's also showing me the placement of that hole. And I believe the A, B, and C dimensions are also changing. All right, so step 5, modify the part. Question 5, modify the part, change those dimensions, and then give us the overall mass. So the first thing we want to do is go through and change those dimensions. So C comes back to 44, B to 58, A to 86. If you don't change these dimensions, that's one easy place where you could go wrong. If you've just done the feature changes without changing those measurements, obviously that can lead to issues. Now for these sketches here, we can see this one in the middle. It's a circle cut. It's offset 12 from that front face. So if we have our sketch plane here, the right plane, we can see it's on the same face here. So I can use the right plane, or I could sketch directly on this face. I'm going to use the plane. And what I'm going to do here is my circle, and the section view tells me where that needs to be and the size. So the size is, it's a radius of 41, which means diameter. So I can go 41, but I need to times that by 2. So I can go 41 times 2. Right, so it's a circle. Now, this line here is pretty clear. It's not explicit, but it's showing you that the center point is in line with that end point. So I'm going to grab this line and this point and make them vertical. And then it's also showing a tricky dimension here. It's not actually showing the center point of the circle. It's showing where it intersects with this edge here. So what you can do to get that dimension is put a sketch point on the circle, drag that over to the line, make it coincident, and then dimension it from this edge to the point to put in that 36 millimeter dimension. Now this sketch is the one that we can do an extrude cut. I'm going to extrude cut. The distance is 24, but I'm going to make sure that I'm offsetting 12 millimeters away from that face. And the next two steps, I think it's pretty straightforward. We have a hole that's going to come all the way through. So we've got the 11 dimension and the distances, 14 and 14. Now make sure you have those from the right points. That hole goes all the way through. So I'm going to extrude cut through all. And then the other cut, we've got a cut on the bottom section and a cut on the top. Now we can do both of those from the kind of front view. So we do it on this face and I'll do a sketch. And I'm going to draw the sketch here. And I can see from this view, I can see the distance for that edge is 52 from that side wall. And I can also see that there is another cut across the bottom, which is this 19 section. So with that one, I can extend this sketch here, draw up and across, make sure that is horizontal, trim. So this shape that I'm cutting is like an L shape. If you have difficulty seeing or understanding the contours on your sketch toolbar, turn on shaded sketch contours and it will give you a preview of the area that you're cutting away. So then if I look in 3D, I'm kind of cutting away this material, and it's going to go an extruded cut of 19 millimeters. Then the last check you want to do before submitting your answer is just have a look at each of the 3 views that it gives you and just make sure things are matching up. So again, it's like spot the difference. Does it look correct? If so, then you're ready to submit your answer. Our answer here is 628.18. And we can see the answer here, number 5, 628.18. I'm going to save, and that's how you do those next 2 questions after the very first model. The next questions from 2 users both relate to actually the next question in the exam. So we will go through and follow that one in detail, which is step 6 here. In this one, we're kind of adding a cut into the sidewall, and we've got a certain thickness that we're cutting to. A, B, and C don't change. So the notes here give some information. Only one pocket on one side is to be added. The modified part is not symmetrical. Assume all unspecified dimensions are the same. So we don't have to change any dimensions that we've already done. We just need to add new detail. Save as question 6. And so the 2 questions I had, question from Sun and Death 5713. For question 6, they got a mass of 426.55, but followed every step and got the other answers correct. So they had everything up to this point correct. Just means that along the steps here that we're about to go through, something went wrong. And if you find that through the sample exam, you can just backtrack to where your file was, repeat the process, and if you keep getting the wrong answer, then it's something in your process or something that you're misunderstanding with the dimensions that are really getting you caught out. And then also another question from Shelby Sumter. On number 6, how did you know it was 1? I'm assuming they mean 1 millimeter. So I'll get to that one as well. All right. So there's a few ways of doing this. The important thing here, I think, to look at this section view, you can see that the material is being cut from this face, and then it's going deeper in this section, and it's going deeper up to this wall. So if I'm looking in the 3D here, the cut is going to go up to this wall, and we can see the 12 millimeter dimension. We already know that that's 12 millimeters from the original cut, so that makes sense. And then on the sketch here, might be a bit small for you to see on screen if I just blow that up a little bit. All right, so we're creating a 1 mil wall thickness around this section. So that's what this 1 typical means. It's referring to the dimension here of 1, but the TYP means typical, and it means that all this wall is going to have a 1 mil wall section. The TYP is common abbreviation used in drawings, just to save you putting a 1 mil dimension in like 5 different places for something that should be pretty obvious. All right. So let's do that sketch. Now, that sketch is going to be on this face. And for this sketch, we're going to use the offset tool. So I'm going to go new sketch. I'm going to go offset entities. And I'm going to change the dimension to 1. And then I'm going to make sure it's offsetting to the inside and press OK. Right, now that's the first step. Now we're going to do this extrude cut in 2 steps. The reason being, the first one only comes up to this wall, and it's going to be 1 mil thickness as well. We're going to assume that the 1 mil from the side view matches the 1 mil from this section view. So it's going to go 1 mil up to or offset from this face. So we can do that sketch, that cut first. So we'll go extruded cut, offset from surface, this surface, and then we change the number to 1. I'll make sure the offset is on the inside, not the outside. So you can reverse offsets and go both directions. Make sure it's on this side. Press OK. Right, and that is the first cut extrude. And, you know, to check what we're looking at here, we could do a section view. So I'm going to grab the top plane, a section view. And if we just have a look here, we can see, like from the top view, we're getting that similar sort of look. All right, you could also put on, keep the cap color. All right, so that first section on the bottom, that looks right. Now we have to do that deeper cut on the left-hand side. Now for that one, I'm going to do a sketch on this face. Instead of offsetting this time, I'm going to convert entities. So I've just converted that inside face, but I don't want to cut this whole thing out. I want to use this edge as a reference because I need that edge. I need to keep a 1 mil wall thickness there. So I'm going to select that edge, press offset, change that to 1. I have to make sure it's offsetting to the right side. So I want it to come on this side, onto the left, press OK. Now, if you want to here, to clean up your sketch, you can use trim and trim away everything you don't need. Or you can just leave it as is. And then you go features, extruded cut. If you left it as is, you select the contour, which is on the left. And then we're going to go direction up to surface. And it's going to go up to this face. We press OK. And now we've created the changes that we need to the geometry. If we look at a section view, we can see now we have a section view that's matching what we can see in the drawing. And our answer, which should be right now, 432.58. Now we see the answer to question 6, 432.58. All right, back to question 3 for our next comment or question in YouTube on the video. And there's a few people who have had this problem. We've already kind of addressed it in an earlier response. Morgan Fabricatori and Makey XX9214 also had this issue where their mass was reading at 958, rather than 939.54. And the reason for that is the dimension we mentioned earlier, the 29. We're going to get what we saw earlier. So if this dimension is actually coming from this point rather than the outside, and I change that number to 29, press OK, you can see our weight is now 958.34. Right, so a few people have got that. So again, that's all about looking at your dimensions, where they're actually coming from, not just the number, but being very careful about where the dimension comes from relative to the sketch. To put that back and to show you that little trick, when you have a dimension, if you want to change that dimension, you actually don't need to delete it. It can be a bit fiddly sometimes, but what you can do is just click one of these endpoints here, and I can drag that to another point or a line or somewhere else entirely. And that's going to drag it to that line. It's going to update the dimension to whatever the same measurement would be, like if it's moved. But then I can just go in and type 29 and it will stay. So anyone coming across that 958 issue, you know that's the point where you're getting stuck. Well, the next comment on the video was from 661MXM, who brought up what can be a really frustrating issue for beginners, not understanding or seeing what's happening as they're sketching their parts. Let me read this out and see if this applies to you. You'll understand. Straight up impossible for me. I've restarted it 20 times now, and every time I sketch the first part of the model, it's overdefined, so I cannot put in every dimension. I delete the problem ones and try and re-enter them. But then the model is not correct dimension, so I can never get the right answer. Forward everything step by step, but every single time it's overdefined. I'm genuinely at a loss what to do. Okay, so the issue is that as you do sketches in SolidWorks is trying to help you, is going to add automatic relations to your sketches to try and speed things up and make it easier for you. So what that means, if let's just try and do this sketch again. I'm going to do a new version. All right, I'm going to start a completely new part, and I'm just going to sketch it without adding anything, like without adding any dimensions. And we'll see how many different relations actually get created without us even, trying to sometimes. So I'm just going to put this one in to start. So we have a reference point, this is the 14. All right, so let's say I'm going to start here on the left. I'm going to go up. I'm going to go across. So already there's a vertical relation on that vertical line. Across, horizontal. Now I want to go down a bit of an angle. Here I want to get tangency. So there's a tangent relation there. I'm going across again. Down. Here there's a perpendicular relation. Now see where that perpendicular relation is? It's actually going to the other side of the model. We'll come back to that. There's a vertical relation. We've got an angle one here. You can see as I move the cursor around, see here, it's like showing me, it might be perpendicular to that point. Okay, those little dotted lines, we don't want that. There, horizontal. This one you can't do. So I have to exit the sketch. I'll come back to it. Let's keep going on the other side. So here, another perpendicular relation, horizontal, do my little radius here, arc, and another little radius arc. Okay. So all of these relations, apart from this coincident on the origin, all of them are added automatically by SolidWorks. This one here, this is a perpendicular relationship between two sketches on either side of the model. And then there's a third one added here, actually. Right now, it just so happens in the sketch and the shape that SolidWorks have done for this sample exam that those are 45-degree angles. So the perpendicular works. The perpendicular is 90. Right, so maybe they did that on purpose. But some of these other relations, you can get really stuck on. Right, like one that might happen is, let's say, this center point here if accidentally that center point was like horizontal to here and you didn't know it. Okay, that's going to give you an issue trying to add in this 19 dimension and then the 19 dimension between that center point and here. It's not going to work. The other things that I can see regularly are, not in this example, but in others, like people might be wanting to do lines at a certain angle, but then, you know, let's say this one was fully defined and they want this one to be a different angle. Well, they can't do it because it's already got a parallel relation to another line already there. So the way to correct this, or the way to deal with this issue is, firstly, make sure your sketch relations are showing like we looked at earlier in the video. If you can't see them, they're getting at it even if you don't know, right? So like here, I'll see it for a second and then it disappears. All right, I can't see that there's a sketch relation there. Have it showing. So that's the first thing. Make sure they're showing, but then also be really aware of what's being added as you're creating your geometry, as you're creating your sketches. And if something gets in there and it's not quite right, like let's say here, I'm doing a circle, it's on the midpoint of this line, but I actually didn't want it to be in the middle. I just wanted it to be coincident. Well, get in there, select that relation, delete on the keyboard, so you can then move it and put it somewhere else. Just need to practice, understand what's happening, what's being added automatically, where it's trying to help you. Eventually, that will become like a very speedy thing for you in your workflow, but while you're learning, you have to pay attention. Right? So, great question, great comment on YouTube there. Hope this helps you and any others stuck with that issue. All right, so those are a couple of the top questions and queries that people have had when they're looking through the CSWA sample exam. I think we've identified here a few things that you just need to be aware of as you're going through. And as you are learning, you are a beginner, okay? You're trying to get into the software, understand. These things take time. Don't rush through it. It's probably my number one advice. Just get the practice in. You probably only need 20 good hours of practice to get the CSWA complete. But if you really want to nail your experience in the software, you probably want to do 40 to 60 hours before you take that sample exam. Although the issues we've seen are around sketch relations, understanding what's happening, and also the dimensions, just being really clear on where your dimension is starting from and going to, and what those numbers are. If you can follow those steps, if you can set up your sketches in the right way, that the dimensions and relations are working, and you get a fully defined sketch, and you can get the first answer for the modeling question right, question 3, often the rest of the exam will be a lot easier. If you're struggling, that's normal. You're learning a very powerful tool, and the CSWA expects precision. You can pass this exam. But if you've already restarted the practice exam 20 times, you're the kind of person who's going to get there. Just persevere, seek out the right help, get the answers you need, and you'll be right. All right. Best of luck out there. See you in the next video.